Hello everyone and welcome back to the channel. If you're new here, this is Corporate Connection where we learn AI, ML and data science from absolute basics step by step. Now take a moment to look at this image on the screen. This is not just a video, this is an exclusive live session by Corporate Connection. Yes, you heard it right. Corporate Connection is coming live on YouTube. So, get your hands on this free session where you will have hands-on coding as well as live Q&A session and also a live doubt clearing session. All of this is happening this Friday at 6:30 p.m. So do not forget that Corporate Connection is going live. So, you will be learning live coding, real project implementation, and we also have a live Q&A and doubt clearing session so you can ask questions directly. Do not forget at 6:30 this Friday live session. Now let's understand what exactly we are going to build today. I'm really excited that you're here because today we are going to learn something extremely powerful yet very simple. Today's topic is student marks prediction using linear regression with Python. Now, don't worry if these words sound big right now. Prediction, regression, Python. By the end of this session, every single one of you will clearly understand what they mean. In this session, we will learn how a machine can look at past student data, like how many hours they studied, and then predict their marks. This is one of the most beginner friendly and important machine learning projects. In fact, almost every data scientist starts their journey with this exact problem. So, today, you are officially stepping into the world of machine learning and data science. Let's begin this exciting journey. Why predict student marks? Now, the first question we should ask is why do we even want to predict student marks? Think about this. If a teacher knows how many study hours affect marks, they can guide students better. If a student knows how much effort is required to reach a target score, they can plan their studies more effectively. Educational institutions can use this to identify students who may need additional support. So, this is not just about marks, this is about decision making using data. This is exactly how machine learning is used in the real world. Not for magic, but for better planning, better predictions, and better outcomes. Understanding linear regression. Now let's understand the heart of today's topic, linear regression. Linear regression is a machine learning algorithm used to find the relationship between two variables. One variable is the input and the other is the output. In our case, the input is study hours and the output is marks. Linear regression tries to draw a straight line that best represents the relationship between these two. Mathematically, it is written as y is equal to mx plus b. Here, x is study hours, y is marks, m is the slope, and b is the intercept. Don't panic about the formula. We'll see how Python handles everything for us. All we need to understand is linear regression learns a pattern and uses it to make predictions. Dataset overview. Now let's talk about the data we are using. Our dataset is very simple and that is intentional. We have two columns, study hours, marks obtained. Each row represents one student. This simplicity helps beginners focus on learning the concept, not fighting with complex data. In real world projects, data sets can be very large, but the core idea remains exactly the same. So, if you understand this data set, you are already understanding the foundation of real machine learning projects. Data preparation and visualization. Before we train any model, we must understand our data visually. This is where data visualization comes in. We plot study hours on the x-axis and marks on the y-axis. Each dot in the graph represents one student. If the dots form an upward trend, it means more study hours generally lead to higher marks. Visualization helps us answer a very important question. Is there a pattern worth learning? And in our case, yes, there is. This step is extremely important because a machine learning model is only as good as the data it learns from. Building the linear regression model in Python. Now comes the most exciting part, building the model using Python. We use Python libraries like NumPy, Pandas, Matplotlib, and scikit-learn. With just a few lines of code, we import the model, create the model, train the model using data. This training process means the model learns the relationship between study hours and marks. Python makes machine learning accessible to everyone, even beginners. You don't need to be a math genius, you just need curiosity and consistency. So, to look for NumPy, Pandas, Matplotlib, please refer to the previous videos I have uploaded. Model evaluation and predictions. Once the model is trained, we test it. We ask the model questions like, if a student studies for 6 hours, what marks will they get? The model uses the learned line and gives us a prediction. We can also visualize this using a line of best fit. This line shows how well the model understands the data. If the line passes close to most data points, it means our model is performing well. This is how machines make predictions, logically and not randomly. Enhancing the model. Our current model is simple and that's good for learning, but in real life, we can improve it. We can add more features like attendance, sleep hours, practice tests, previous performance. More relevant data can improve prediction accuracy. Machine learning is an iterative process. We keep improving models step by step all the time. Real world applications and benefits. This exact concept is used in many real world applications. For example, predicting house prices, predicting sales, predicting stock trends, and predicting performance outcomes. Once you understand linear regression, you unlock countless possibilities. This is why linear regression is often called the gateway algorithm to machine learning. Now that you understand the theory, let's build this step by step in Python. Open your Google Colab or VS Code. Let's start coding. Step 1. Import libraries. The very first thing we do is import NumPy. NumPy is a Python library used for numerical calculations. In machine learning, almost everything revolves around numbers, arrays, matrices, vectors, and NumPy helps us work with them efficiently. Here, NP is just a short name so that we don't have to type NumPy again and again. Next, we import Pandas. Pandas is used for data handling and data manipulation. Whenever we deal with tables, columns, rows, CSV files, or Excel data, Pandas is our best friend. Here, we use PD as a short form for Pandas. Next, we import Matplotlib, specifically PyPlot. This library is used for data visualization. Visualization helps us see patterns instead of just guessing them from numbers. We use PLT as a shortcut for PyPlot. This is the most important line so far. Here, we are importing the linear regression model from the scikit-learn library. Scikit-learn is a machine learning library that already contains ready-made algorithms. Instead of writing linear regression from scratch, we simply import it and use it. Now, let us play the run button and see. Yes, so it is successfully executed. Now, let's start creating the data. Step 2 is to create dataset. Here, we are creating our input data. These numbers represent study hours from 1 hour to 10 hours. We use np.array to store the values in numpy format. Now, very important part, reshape -1 to 1. Machine learning models expect input in 2D format, not 1D. So this reshaping converts the data into a column format which the model understands. Very important part, using reshape from -1 to 1. Machine learning models expect input in 2D format, not 1D. This is our output data. Each value represents the marks scored by a student corresponding to the study hours. So if someone studies 1 hour, marks are 35. If someone studies 10 hours, marks are 80. This creates a clear relationship between input and output. So let us click on the play button. Successfully executed. The next step is data visualization. Step 3 is to visualize the data. Now we visualize the data using a scatter plot. Each dot represents one student. The x-axis is study hours and the y-axis is marks. Here we label the x-axis as study hours so that the graph is easy to understand. This labels the y-axis as marks. We give a title to the graph so anyone looking at it immediately knows what the graph represents. This line displays the graph on the screen. Always remember, without plt.show, the graph will not appear. So let us click on the play button. Successfully executed. And here we have our scatter plot. So study hours on x-axis, marks on y-axis, and we all the input and output marked here. These are the data points. So we have corresponding numbers. The title study hours versus marks. So this is scatter plot. Next, let us go towards model creation and training. Step 4 is to create and train model. Here, we are creating the linear regression model. Think of this like creating an empty brain that is ready to learn. This is where learning actually happens. The fit function trains the model. It looks at study hours, looks at marks, finds the pattern and learns the relationship between them. So upon finding the pattern, learns the relationship between them. So the model that is being used here clearly is a linear regression model. The next up is the model parameters. Step 5 is to view equation. This prints the slope, also called M. Slope tells us how much marks increase when the study hours increase by 1 unit. Intercept is the value where the line cuts the y-axis. It represents the starting point of the prediction. Let us click the play button. So the slope here is 5 and the intercept here is 29.9 bar. Let us move ahead with prediction. So step 6 is prediction. Now we ask the model a question. If a student studies for 6 hours, what marks will they get? The model uses the learned equation and predicts the answers. This prints the predicted marks on the screen. This is the real power of machine learning, making predictions on unseen data. So let us click the play button. So the predicted marks for 6 hours is 60. Moving on to the final visualization, step 7 is plot regression line. We plot the original data again. This red line is the line of best fit. It shows how the model learned the trend from the data. Finally, we display the complete visualization. So let's click on the play button to view the final visualization. So this is the obtained scatter plot, the final visualization. So we have steady marks on x-axis, steady hours on x-axis and marks on y-axis. The color used is red and we have scatter plot visualized here. So this here is the final visualization obtained. So congratulations, you have just built your first machine learning project using linear regression. If you understood this, you are officially on your ML journey. Please like, share and subscribe to support the channel. And don't forget, this coming Friday at 6:30 p.m. Corporate Connection is going live. So there we will have a live hands-on session with doubt clearing as well as live Q&A. All comes at absolutely no cost to you. Just join our live session at 6:30 p.m. this Friday. So see you live. I hope I meet all of you there. Happy learning, happy coding, and yes, do not forget to subscribe to support the channel. Thank you.